What's up everyone? Welcome to the MK Labs. Glad you're here. This is the second video as part of the AI Native Quality Engineering series. Video 1 was the terrain. What production AI actually looks like and why testing it is hard. If you watched it, great. If you didn't, please go and check it out, and I'll also drop a link in the description down below. This video is what happens once you're standing on the terrain. Same problem every engagement. Different stacks, finance, healthcare, dev tools, different scale, pre-launch to live production. 3 patterns underneath every single time. Patterns that quietly turn your test suite into a theater. So that's the video. 3 anti-patterns I see in every testing engagement. For each one, what's actually broken, why it breaks, the way it does, and what to replace it with. So if you own quality on production, AI system, this is for you. In next 20 minutes, 3 patterns you'll be able to name in your own test strategy by Monday morning. 3 replacements that hold on. Let's go. Alright, a quick gut check. 94% pass rate sounds great, right? 237 passing, 12 triage failures. If you saw the dashboard, you will feel safe. Now here's the punchline. The system shipped the wrong currency 3 days later. The number was real. The bug was real. And that's exactly the point of this layer. In AI testing, you can have green signals that are technically accurate and still be strategically useless. So when I say anti-patterns, I don't mean theory, I mean patterns that create false confidence at scale. The kind that gets teams blindsided while the metrics look healthy. Today we will name 3 of them. So when you see a pass rate like this, you will know whether it's a signal or just a number. Let's hold 2 truths at the same time. The pass rate was real, the pipeline did what it said it did. The bug was real. The customer still got the wrong outcome. This is the trap. Teams treat a single metric like a pass rate as a proxy for quality, when it's often just a proxy for what your tests are able to see. In AI systems especially, the failure surface is messy. The model can be fine, and the user experience can be broken, or the output can look acceptable while violating a load-bearing requirement. So if your quality story ends at it's passed, you're not done. You're just done looking. Welcome back to the MK Labs. Video 1 was the terrain, what production AI looks like, and why it's hard to test. This session is what teams do wrong on that terrain. The 3 tabs I see in every AI testing engagement. And I'm not talking about niche cases. Different stacks, different industries, same underlying failure modes. The patterns sit underneath the test strategy so you can have impressive artifacts, impressive dashboards, and still be fragile. The goal today is simple. You'll be able to name 3 anti-patterns in your own setup, and you will lead with concrete replacements. Things you can actually implement, not just be more careful. Let's get into it. If you saw video 1, what production AI looks like and why testing it is hard, this is the follow-up. If you didn't, you don't need to. No, you should. Video 1 was the terrain. This one is the 3 traps I see teams fall into on the terrain every single time. If you want quality on AI systems in production, or you're building towards one, this is for you. No toy system, production systems, where being wrong has a cost. What you will leave with again is 3 patterns you'll be able to name in your own test strategy by Monday morning, and more importantly, what to replace it with. Here are the 3 anti-patterns. Different domains, same roots. Anti-pattern 1. Human reviewer as the only safety net. When the reviewer is the first filter, the reviewer becomes the ceiling, and that ceiling is tired by Friday. Anti-pattern 2. Vibes-based eval. LGTM looks good to me. One person's taste, dressed up as a quality gate, they leave and the gate breaks. Anti-pattern 3. Snapshot equality on LLM output. Yesterday's output equals yesterday's output. That's not asserting quality, it's asserting history. Notice what these have in common. They all look like process. They all produce numbers. They all scale poorly. The moment volume increases, team members change, or the model drifts, your quality story collapses. Now we will take them one by one. Story, diagnosis, and the replacement you can implement. Anti-pattern 1. Human is the only safety net. This often starts with a good intent. We will have a senior tester in the team review a generated artifact. It feels safe because you can trust them. You can point to the person and say, we checked it. But here's the rule. When the human is the first filter, the human is also the ceiling, right? The ceilings are tired, distracted, and honestly, have a Tuesday. Think about your own team for a second. Who's doing the reviews? How many artifacts are they seeing per day? What happens when that number doubles? Because the AI generated output, it will. That's the part nobody plans for. So the question isn't are our reviews good? The question is, did we design a system where human attention is a primary control? Because attention doesn't scale and AI output volume absolutely does. Let me show you exactly what it looks like in practice. Recent engagement, GraphRag, we spoke about it, has a multi-agent system generating artifacts for financial domain client. A senior tester was assigned as a human in the loop, smart, experienced, 25 years plus on the tools. Week 1, catching 4 meaningful issues per 100 artifacts, spending around 4 minutes on each one, reviewing about 80 a day. The system's working, catches are flowing in, and the leadership is happy. Down the line, 6 weeks later, same person, same artifacts, output volumes quadrupled. We're up to 320 a day. Catches 0 per 100. Time per artifact after 30 seconds. And here's the part that should chill you, right? Leadership read the failing catch rate as quality going up. The system wasn't getting better. They thought it wasn't. The reviewer had hit the wall. They were just clicking through. Let's diagnose it clearly. The failure isn't the reviewer, right? Not blame the humans. The failure is a design choice that put a human there as the only line of defense. When scrutiny per artifact drops below a floor, catches stop being a quality signal and start being a volume artifact. It's a psychological ceiling. Every human reviewer has one, and designing a system that depends on a reviewer never hitting theirs is designing a system that will fail. And the flattened curve looks comforting until you realize it's not measuring quality, it's measuring human saturation. This is how you get the toast notification test. It passes for weeks, the process is intact, the checkbox is ticked, but the reviewer has stopped truly reading. So if your quality strategy relies on a person will notice, you have built a system that works only on low volume. The AI systems do not stay low volume. Replacement, layered defense. That's the way to go. Humans still matter. Not saying human in the loop is not required. Don't get me wrong. Humans still matter. But they are the last line, not the only line. By the time an artifact reaches a person, 3 filters have already done the heavy lifting. First, schema checks. Can the structure parse or fields present or the types correct? This catches the cheap failures fast. Second, property checks. Required entities present, banned entities absent, invariants hold. This is where you assert what must be true regardless of phrasing. Third, model graded evaluation. A held out set, a reproducible rubric, a threshold gate. Now you're testing a quality in a way that scales and repeats. Finally, human samples. Sampling, not a blanket review. Humans focus where judgment is needed, not where machines can verify structure and constraints. If your reviewer is the first filter, your reviewer is your ceiling. This design removes the ceiling. Number 2, vibes-based evaluation looks good to me. This is when quality gate is really just someone's internal threshold. Taste, intuition, personal standards, depends on their mood, without a reproducible way to reach the same decision again. And the litmus test is brutally simple. If 2 qualified humans can't produce your fail and pass decision, you don't have an eval. You have a preference. It might still be a smart preference, but it's not a stable gate. As soon as the score changes or the team scales, you get inconsistent results and false confidence. So this anti-pattern isn't humans are bad, it's we pretended a subjective judgment was an objective measurement. Here's the story, right? A senior engineer leaves, new owner runs the same eval 1 week later, 20 points up, same model, same prompts, same data. But the score goes from 72% to 92%. That's not the model improvement, that's a measurement problem. The eval was measuring one person's threshold more than it was measuring a property of the system. And this is why base gates are fragile when the gate depends on a single person's intuition. The gate is portable only inside that person's head. When they leave, your quality metric becomes a coin toss. So if your KPI can change that much without the system changing, the KPI isn't describing the system, it's describing the scorer. The diagnosis is one question, right? Can two qualified humans produce same pass-fail decision? If the answer is no, you don't have an evaluation. You have a preference, as I mentioned earlier. And the risk isn't just inconsistency, right? The risk is organizational. The person can leave on Tuesday or Wednesday. When your quality gate is implicit, undocumented, or we just know what good looks like. You're building a system that can't be maintained, it can't be audited, it can't be proved systematically because you can't even define what better means. So the fix here is not train scores hard. It's to turn the eval into something that exists outside any one person, something the team can repeat, trust, and test. So the fix here is not train the scorers harder. It's to turn the eval into something that exists outside any one person, something the team can repeat, test, and trust. All right, how do we fix it? Replacement 2, a reproducible rubric. This will definitely help you, and this is something that we implemented as part of the previous story. The eval pipeline should have a reproducible rubric. In that way, you know how things have gone, and then you can be consistent, you can have an audit trail, right? The goal is simple. Make an eval a property of the system, not a property of person scoring, right? Write a rubric down, actual criteria, worked examples for each level and edge cases called out by name. Two qualified scorers independently, same items, no conferring, score, then compare. This forces clarity and exposes ambiguity fast. 3. An inter-rater agreement gate. Don't let the eval gate the system until the eval can pass its own test. Because if your rubric can't produce consistent scoring, it's not ready to be used as a quality gate. This is how you stop looks good to me, LGTM, from being your release criterion. Anti-pattern 3. Snapshot equality on LLM output. This is where teams treat the model's output like a deterministic program. They store a golden response and assert the next run matches it exactly. And when it doesn't match, the test fails and the workflow is to re-snapshot a new output. At that point, the test isn't testing quality, it's maintaining a commit log with extra steps. It asserts nothing except the model said yesterday what it said yesterday. So if you ever found yourself thinking it failed, but the new output looks fine, just a bit too golden, you're not alone. I've done it, people have done it, but that's an anti-pattern for sure until we realize we hit a major problem. And it quietly deletes the meaning of your green checks. Here's the story. The drifting golden file. 3 months, 40 re-snapshots, and one paragraph nobody had read in weeks. The version 1 says verify, version 7 says validate, version 21 says confirm, version 40 says check. Nothing is getting more correct here, it's just drifting. And because the team keeps updating the snapshots, the test stays green. So what is the test actually asserting? Only that yesterday's output equals yesterday's output, because you're constantly redefining expected to be whatever happened most recently. The danger is subtle. You still have coverage, you still have automation, you still have pass rates, but your tests have lost the ability to tell when something meaningful broke. Here's the keeper for anti-pattern 3, right? Properties and not equality. Assert what has to be true, not what output happened to be yesterday. First, structure. Output parses, schema validates, required fields populated, types correct, no malformed JSON, no half-emitted markdown. Required entities. Load-bearing entities must be present if the artifact must reference customer ID, currency, timestamp, any metadata. Assert those by name, not by type and shape. Banned entities. Forbidden content must be absent. PII. Very important, right? Internal host names, prompt leakage, prior conversation context, hallucinated counterparties, and semantic validity. The claim still holds even if wording changes. Use semantic equivalence on the local bearing assertion. Model graded or embedding distance, not literal string match. And one hard rule, re-snapshotting on a failure is a policy violation. Failures get investigated, never rubber stamped. So the replacement 3 is operational version of that. Replaceness snapshot equality with property assertions. If your test auto updates on red, it's not a test, it's a commit log with extra steps. What do you want in a suite of assertions that survive drift, structure checks, required banned entities, and semantic checks on a local load-bearing claim? When it fails, you don't refresh expected, right? You investigate. Was it a model drift, prompt change, a retrieval shift, a new edge case? The key is that the failure should create information, something you can act on, rather than creating a busy work that keeps the dashboard green. So failures get investigated, not rubber stamped, not re-snapshotted. That's how your tests stay meaningful over time. Let's bring it together into 3 Monday actions. 1 layer defense, schema, then properties, then model graded eval, then human samples. Humans are the last line, not the only line. Reproducible rubric, written down, 2 qualified scorers and inter-rater agreement gates, the eval before the eval gates anything else. Property assertions, structure, required, banned, semantic, and treat re-snapshotting on red as policy violation, not a workflow. If you implement these, your dashboard starts to mean something again, because the gates measure durable properties instead of human attention, personal taste, or yesterday's wording, or depends on the mood. This is how you stop being surprised by, how did that ship moments? Now we can return to the opening number. With the layered defense, reproducible rubrics and property-based assertions, 95% starts to become a signal because it's grounded in checks that scale, repeat, and actually assert what matters. But skip those foundations and it's still a number. It's not just telling you what you think it's telling you. And that's the real risk with AI in testing and production. You can be surrounded by green while drifting into a failure. So use the pass rate absolutely, but only after you've built the system underneath it that makes pass rate meaningful. 3 anti-patterns and the replacements that actually hold up in production. If this resonated, it probably means you have seen at least one of these in a while. The reviewer sealing, the looks good to me, or the drifting golden file. The video 3 is coming. More of the layer, more of the practical mechanics. We will deep dive. We will talk about what frameworks you can use to have a layered defense. First line of defense, the second, the third, maybe fourth and fifth. Or more of what to do next once you have stopped the obvious leaks. And thanks for sticking with me to the end of this one. If you want the rest of the layer, subscribe. And in the meantime, pick one of the 3 Monday actions and implement it this week. Start small, but make it real. Because in AI systems, the difference between a number and a signal is the design underneath. I'll see you in the next video. Until then, take care.